I didn't even know I was going to stream today. I didn't even know. I'm live. Hi there, guys. I had no announcement. I guess I should announce it of some sort. I guess I should announce it. But we're going to watch the Nvidia thingy all together. No one's watching yet, so it doesn't even matter. I'm not even just talking to the replay. Woo! No one's watching yet. That's not good. Twitter. I'm going to tweet it. I'm out live with Timmy Joe and watch. Yeah, that's right. I'm typing. And announce their new GPUs. I'm good at spelling. Announce. Tweet. How do I tweet the stream? What's the stream URL? Ah, everyone's seeing. Hi, 12 are watching me. How's it going, guys? We're gonna watch the Nvidia thing together. I gotta do it. I gotta do it a lot. So what's up, my friends? I'm watching it, and we're gonna watch it together. I don't know how to get my. Oh, there we go. Live now. There we go. You could hear me say things. Tweet. There we go. So, what's up, guys? It's Timmy Joe. We got some people say, hey, how's it going there, Aaron Barnes? Ha, I'm watching, sir. How bad is the delay? Well, it's live, so. This guy. Look at this guy. So, how's it going, guys? 60 viewers now. Woo! We're going to watch it. We're going to watch the fuck out of this. It's going to be awesome. I actually have, watch this. Here, we'll just shut this off for a sec. I'm working on a video where I test. If I go like this and whoop, make me big there, and I just pan over here. There's a system, and that's a 1080 Ti right there, because we're going to be testing the old 1080 Ti for the last time, because I got to get rid of mine to get the new one, which you have to test it before you get rid of it. So that's what we're doing in a video today. But if I can get this freaking thing moved over, there we go. For today, we will be watching the Nvidia event, and we should unmute it. Yeah, we're gonna be watching this. We're gonna make this. Oh, that's so loud. Can you guys hear it? I need to know. Tell me if it's too loud. I heart you guys. You consider reviewing more AGP graphics cards? Yes, I'm working on a schedule. I'm gonna review old graphics cards on a certain day every like 2 weeks, old CPUs on a certain day every 2 weeks, stuff like that. But I guess it would be, yeah, it'd be fun. Can hear it now, Timmy Joe. Better still quit. You want it louder? It can be louder. Look at those people all taking pictures of the stage. Something crazy is just about to happen any second now. This is going to be so fun. Timmy Joe, you get your flow tonight, bro? Look at your gung-ho.
So nice to see you.
Well, hi, I'm back.
What? What? I thought we were going to have a secret handshake.
Are we doing a secret handshake?
Oh, I don't care about that girl at all. Purple hair. Not loud enough. Well, we don't want to listen to them. We want to listen to me until the important stuff's happening. Hello, I want to watch a video with you. Thanks, Garrett McReynolds. I love your name. It's a good name. What's up, Clint Moore and Joe Cage and Harrison Price and Wesley Vanderosen? Louder! 1080 Ti for 1K. Yeah. Well, I'm used to the 1080 Ti being $1,000 in Canada, so I can only imagine it'll be like $1,800 for us stupid Canadians. And our dumb monopoly money. That's not very nice. What's up, Edgy Boy? What's up, curious about performance GTX RX on Scott Spar? I'm curious, man. What's up, Dexton Anderson? You guys are my bras. More volume. Can you hear me at least? I'm sure I'm just yelling at you. I'm not peeking. So, you want to listen to these guys, these chumps? We can listen to the chumps.
But she's really good at it. like top 10 usually.
There you go.
You know,
just
well,
with the
as long
bush
as
strat.
don't hit the buildings because that's the worst place to go. Make sure that you hide in the bushes and in the forested regions.
And then just let everybody else kill each other.
Let everybody else do it.
Yeah, that's my strategy in
That's
general.
what I want to watch.
So you got
A
to
girl
actually
talk
talk
about
to some people out
Fortnite.
there. I got to talk to Ron Christensen, a modder. He built a case that you
That's gonna
already
be something
saw
we're gonna play
that
on
you're
the
pretty
channel, I
excited
think.
about. And as I
I'm gonna get
understand it,
some
we're
of you
actually going to be
Fortnite
giving it
people
away.
to come play with Timmy Joe.
Can I get
and
it?
show me how it's done.
No, I'm
No.
So I hope show launch is over. I'm at work, so you can keep it down, please. Sorry, David Wright. Okay, volume is good. Needed a better speakers. Oh, there you go. Will you getting new cards? Well, I have not been asked ahead of time about it, but I'll work my hardest, and I'm going to buy it if it's available soon. But we'll see. There we go. Now I got the better setup going on. What are my opinions about ray tracing technology? Cool or just novelty? Well, it'll be really cool once the technology hits. Like, if it's actually doing as good as, like, apparently there was like 4 Quadro cards running one of these ray tracing things, and they had to pre-render it. And then the last time 1 card was running it. If the ray tracing's got so good that 1 card can do some of these effects we've seen in these demos, then yes, it'll be very, very cool, and it won't be just a gimmick. I want to play 2080 Ti Minesweeper. Yes, Z I as well. Let's play some Minesweeper. You can't even play Minesweeper. Can you play single-player puzzle video game? You can't even. It's not even on Windows anymore. It's so sad. 70,000 people are watching. Well, 111 are watching Timmy Joe, so tack on another 111. I had to turn the AC off. It's going to get hot in here. Ah. All right. Of course, it's 12:03 and they still haven't started. But there's some good music out. Dance mode. Timmy Joe's all that matters. How do I prime sub? I don't have that ability yet. One day. I'm going to check into it. I had a strike, so I wasn't able to get any of those prime things or live stream until just a few days ago. Well, the beginning of the month. So, it's pretty crazy. I don't understand this Twitch chat. Look at how crazy it's going. Boom, 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 boom. Thanks very much, guys. I'm super, super happy to hang out with you guys, and that every one of you comes and all 180 of you come and hang out with me and go to watch this freaking event, assuming it ever starts. I guess I'm having a yell over the music here. There we go. Music's better now. Oh, look at that guy. He's like frantic. He's like, I gotta get my monopod out! I got to get my monopod at full extension! Good thing that's the camera you're showing right now. Alright, let's talk to you guys. When are you coming back to Canada, Computers in Vaughan? I would like to meet you one day. Love your videos. I would like to organize I'm going to go down south and try and pick up some hardware deals and make a video out of it. Because we have really, really bad hardware deals where I'm from. So to go down south to Toronto and like try and beat some people up on Craigslist, Kijiji, and such.
Shannon had to go and talk to other more important people, but I
hate this nerd.
You're still here, and the great news is you can get involved. Like I said, we're going to be showing off some stuff that probably
we're going to end up
just and you're going to have lots of questions
dragging on and not actually starting the show at 12, are you?
You can ask those questions. Go ahead, type them out. We're going to be talking to devs of some big games and some smaller ones too.
I'll type some stuff here.
Show off. We're going to be showing
Woo!
off some
Timmy Joe in the chat.
Want me to pass that along?
Delta Toronto, is that recycling?
And I will ask them.
Yeah, sorry, I'm not reading.
So
oh, I got a super chat of $1. I love super chats of $1. You're my favorite, Colin Steinke. That was a bad one. Colin Steinke. You're my favorite.
One this big
Up
before.
to resolution
We
of
don't know what's
Nvidia
going
stream
on. There
looked
seems to
kind
be
of
some
bad.
sort of wave building. Everybody I know has
I
a
mean,
green
it's
avatar. There's
settings,
hashtags
advanced,
flying around
quality,
before the
auto,
game.
1080p.
As you may have
There you
seen,
go.
We've got our sweet hype video with "Hold On, I'm Coming" just pumping through the speakers. So we are pretty.
So,
psyched, and we are
1K
not
top cars
quite
locked.
sure
You gotta stream
why.
so
All we really
early.
know
I've got
looking at what
to
Nvidia's
for
done
school.
so far
Sorry,
is
dude.
that
Andrew
they're
Wibben. Oh, 138 people are watching me.
really
I love
got
it.
something probably up their sleeves that you're
I'm
gonna
really
see.
excited about these cards because when I originally reviewed the 1080 Ti, it took me a long time to get one. I had the awesome like Gigabyte Gaming Ultra. Oh, it's starting. Here, we gotta turn it up. And I reviewed it at 4K. Here we go. We're watching some stuff now. Yeah, this is exciting. Yeah, we already saw this stupid video. I'm really negative too. I'm hoping that this is like a real 4K. We need to get to that. 4K is awesome with HDR and stuff like that. We need powerful graphics cards. And if they're eliminating SLI and you want to run a 4K monitor at 100 and some hertz, then I mean, technology's got to advance. We've been at 1080 Ti for what, 3 years now? 2.5 years? We've been close to that performance for a while. We had the 1080 came out 6 months before that. Cologne.
Hey everybody, I am back again here in the Keynote Hall, which is amazing. It is
All right,
packed in
let's
here,
answer
and
some
I am joined by Tutor. Hi, how are you doing?
Great. Video is. The music is ear raping. Okay, I'll keep it down like that. Anyways, hi, let's talk. Hopefully I could pick up another 1080 Ti for cheaper now that the SLI... Yeah, that would be cool. Video is too loud, mate. Well, it's not loud anymore because I turned it down. I'm sorry. I'll make sure that no one's ears get blown out once the actual video starts. This piece of fiberglass covering in chips and fan is so fast. Wow, shit. Sub 600 Canadian. Were you a sub that was when I had 600 subscribers and you were Canadian? I'm waiting for a package too. I might have to run out and grab a package. I got a video. See, look at. I can look at the front. I can look up the front of my office. Woo! I got security cams and shit up in this biznatch. You should do a video about it. Nothing wrong with deep fried Nvidia announcement. How much do you think Asus LGA's Mobo is worth? I mean, depends on which Asus motherboard it is and what chipset. Just that socket's not going to tell me much. $100, $50, $27, $27.99. Can't hear the fat guy. Oh, the fat guy. I'm the fat guy. Yeah.
Hardware, I am the guy actually testing graphic cards and CPUs and stuff like that before launch. So my job is actually testing.
My job is actually putting minion shirt on and coming to a video event.
So that's why I'm also excited about this event.
Perfect. Well, we are so happy that you decided to join us today, and I'm going to go ahead and throw it back over to Julian. Thank you so much.
Just stalling for time.
Welcome back. I'm Julian, and this is little Siha. She is Just Dance extraordinaire. What you doing out here today in Germany?
I'm here to see the Nvidia event. I want to see what all the fuss is about. Everyone's Twitter account is green, and I want to know why.
Yeah, you're in the right place. What do you know?
I literally know nothing.
I should make my Twitter
It looks
account.
like a nightclub in there, and there's like loud.
Yeah, I gotta. Here, what do you want to do?
Pretty cool, but
What do you want to do, guys?
I don't know anything. I have no idea what they're announcing.
What are you gonna do? What if we do this?
Extremely tight NDAs have worked. No leaks so far. Everybody's in the dark. What are you doing out here? And are you coming out to Just Dance World Cup?
They have one going on in Germany at Gamescom.
Oh, it's not gonna work.
At Gamescom, I know we're gonna be doing some stuff at Gamescom. Still don't know what yet.
There we go. Look at this is my 1080 Ti. And what do you want to do? Run Firestrike?
I like seeing you. It's fun.
Will it run Firestrike?
You're also here with I Am Spoon, right?
Yeah.
So does Spoon know anything?
No.
There we go. Yay, I'm back.
Oh, we're under NDA type thing. We have no idea.
We could put the display capture and make it here. and then
Nothing.
make the
No,
Elgato.
I wish I knew. That'd be
This
cool.
is
I could
hard.
be like, oh, I don't know anything. But I have no clue.
Elgato here. Oh, there we go. Let's run Time Spy while we're...
Because it gives me
Yeah! 1080 Ti Time Spy while we're waiting.
I know it.
that I know a thing.
Yeah, I don't know.
I got all the things I can do while we're streaming.
Video, so it would probably be cool.
Hi, how's it going, big man? Walking tree?
Cool.
What CPU you got? It's still 7740X,
Stretching out of your comfort zone,
which
things
is
you might not normally play.
going bye-bye very soon.
It's a
Because
new
I'm
Just Dance
going to be revamping all my test stuff. I just...
Yeah,
7740X, that's the one I got.
yeah, you actually strap it onto each of your limbs.
Could you imagine if you just like attached it to your wrists and ankles? Just had wires. Like,
Always love TJ stream. Thanks, dude. Daniel Jones, I love you.
Then you could do
Nvidia puppet or
Here we go. You could put Time Spy on her head.
right now.
Boop doo doo, I'm a dancing Time Spy.
There's actually no
There we go. Now I don't have to see that guy's ugly face. That chick's kind of cute, I guess. She could say.
just like, yeah, I love this so much. So yeah, I'm excited. I can't wait to see what it is.
Okay, well, you better scurry
It's
in
fun
and
to
have a
just put
seat.
Time Spy
Shannon's
around
out
the
there on
screen.
floor. She's found another influencer that she's gonna needle for information. So
I would
Shannon,
like to get
tell us
another
what's up.
Threadripper, that is for sure. And I have some stuff in the works to make it happen. I have a cooler for it. I'm hoping to get the mega one, the Megalodon.
Yeah, great, thank you. Nice to meet you.
Now, what do you do, Mike? I'm extremely interested in what you do, actually.
Are we
Sure,
gonna
so,
watch?
I'm a virtual reality YouTuber. I have my own virtual reality YouTube channel called Virtual Reality Oasis, where I deliver.
Oh, it failed. Why did it fail?
News and information about virtual reality.
Must be over. Oh, I know why it
What's your
failed,
favorite
because
headset?
this is
I've
open.
tried several
Anyways.
of them, and
I'm gonna
I
get
know
rid of
what my
this.
favorite is,
Boop.
but I'd like to hear it from you.
Sure. So my favorite headset right now is the Oculus Rift, but I do own all of them, so I do use them all
Oculus Rift
regularly,
is his
but
favorite?
The Rift has a special place in my heart as it was the
Must
first
just be
headset
that
I ever had.
easy to
That's a
use.
good point. It
Because
was
the
first one that I
HTC
tried
Vive's
to
so
way back in
hard
the
to
day when you
use.
still got, like, motion sickness from stuff
Oh,
like
she's
that.
got so much blue on.
And that's still a problem today.
That girl
but,
used to
you know,
do
the
a
industry
computer
is
show
growing, and
with
I'm
this
starting to do
guy,
my best
Patrick
to
Norton, with
prevent that from happening, so
man
I
braces and like a
definitely,
bald
get
head.
somewhere with that.
And
Have you tried the new HTC
there was an
Vive
even
Pro?
cuter girl before her, and then I don't know what happened to that channel. Revision 3? It just like went away.
Dude, I'm so jealous.
I know. I have
Remember
the Rift,
that?
I have the Vive
TJ,
Pro,
predictions on
the
performance
PSVR,
between
Oculus
GTX
Go. I'm a
and
collector of
percentage-wise.
headsets.
Well, if you ever need to take any of
It's
those
gonna
off
be
your hands,
just the
let me know.
2080 to
I'd
the
be happy to help
1080?
you out.
Well, you never know, you
Well,
work for Nvidia,
what about the
so
2080
we
to
help each other out.
Ti to the 1080 Ti? I think that's where that's gonna be amazing.
Mike, thank you so much for joining us. Where can people find you on
Even if it's like 40% faster, it'll make it a 4K card.
Really love that you're here with us today, and I'm gonna go ahead and throw it back over to Julian.
I'm gonna go and throw it back to Julian, who's got another person we don't care about talking to stall for time.
Movies, all that good stuff.
Oh, it's the stream is breaking.
What are you doing here today?
What's going on?
For the new stuff from Nvidia. I'm super excited to be here.
I'm waiting for the new stuff from Nvidia.
Well, not really. It's
You
actually
know
just
you're
a
not.
live
No one
stream
wants to see that.
So it's
8K GPU.
Nvidia.
I mean,
So you have
that's a
no
lot of
idea what to
pixels.
expect. You've never seen anything
I'm waiting for 4K camera
Actually,
myself.
I'm actually a user of Nvidia cards, but I've never been to this kind of events. So yeah, I'm really looking forward to see what's going to happen.
What are you gaming on right now?
Jensen's
Well,
gonna
right
show us
now,
his
You mean
boobs.
on my PC or Nintendo Switch? Because Nintendo Switch is powered by the Tegra.
Shh, we're not allowed to talk about that, right? That's
What?
that's an industry secret.
I know.
No, what are you gaming on your PC?
Right now, I'm playing the Graveyard Keeper. It's
I'm
small
playing a
indie
lot
game
of
that got
Roblox.
released recently, but I love it.
Oh, that's the tiny build, right? Where you
Man,
are the,
that chat is
the
so
graveyard
fast. I know,
keeper that
right?
Has to find
like-
less than legal ways to run your graveyard, right?
There's a
Correct,
chat.
correct.
Blah
It's
blah
not
blah blah
that
blah blah.
much about being
Can you guys make
Graveyard
my chat
Keeper,
that
it's
fast?
more a Stardew Valley meets
Chat
the
so
medieval
fast.
kind of
Chat.
theme, like,
Chat,
it's crazy. I
chat,
love it.
Cool.
Roblox.
So that's. Are you more of a fan of these indie games, or do you like big AAA titles too?
Well, a mixture of both actually, because I love to
Do you
play
like
some
video
AAA
games or
big
do you like
titles,
video
when
games?
they got released,
Or do you really
but
like
I also
video
love
games
indie
on Nintendo Switch?
Yeah. Well, that's the joy of being a PC gamer, right? You get to have all those.
I was
in your
thinking
world.
that I was
What
going to be
card are you
late to
using
this
right now?
party, and I was
I
going to
got the
jump in right as the
GTX
stream was happening.
770.
But nope, where we have to
Sweet,
listen to these
solid.
noobs talk, and I'm going to
Um,
stab myself
keep,
in the
keep using that card
brain.
and having fun there,
with
buddy, with
this
Graveyard Keeper.
knocked to my
Jacob,
brain,
thanks so
dude.
much. People want to find you. Where can they find you?
Screwdriver.
They can find me on YouTube as Pan Kubaka. It's in
You can
Polish,
find me
so
on YouTube
It's
as
not-
Chewbacca.
You know, if you speak Polish, go find it.
Exactly.
I'm
Thank
sorry,
you
but if
very much.
anyone's Polish and I'm making
Well,
fun of your
Jakes,
accent, that's not
thanks
cool.
so much. Shannon is out there on the floor. Shannon, what's going on out there?
I want to play Roblox. Oh, good. We can't hear. You can't hear.
Music in here. It
Oh, there
is
you go.
so much fun. And I am joined by Dennis. Dennis, what is up? Thank you
All
so
right.
much for joining us.
Cheers. Thank you so much for having me.
I would have prepared a little more if I knew it wasn't starting right away. This is annoying. If the rumor price of the RTX 2080 is $799 is true, I'll probably buy an RX 580 for $249. She finally shuts up. That's funny. Yeah, this will leave a lot of really good performing GPUs at 1080p on the table to just creep lower and lower in price, which will be very nice because we've been having such a hard time with the mining bullshit. I'm glad mining like went away. I have a buddy who bought 15 or 16 RX 580s to mine with the second the fucking price dropped. Like, he bought them and he got them all up and running like the day everything tanked. And I've been trying to get him to sell me some of these RX 580s because I need some for my computer business. And you can buy one on eBay right now, like an RX 480 or 580 for like under $300 Canadian, easy. And he paid almost $500 each for them. And he just won't give them up, thinking that mining will creep back up. But by the time mining creeps back up, something better will be out there to mine with. You know, so 3-way 980 Ti. I wish I missed my 980 Ti. That was my favorite card, I think. I really, really like that. We're gaining momentum, though. We got 161 people watching me rant over this purple-haired girl. Here. Back to you, Timmy Joe. I've got Grumpy Cat. Are you really excited about watching the new Nvidia GTX RX come out? Nope. Fuck this shit. Back to Timmy Joe with Domo. Do you play video games and like Nvidia's cards? Fuck the Nintendo Switch. I'm just playing Game Boy. Oh man, it's getting hot in here. I turned off the fucking AC. I can't say the F word or I'm gonna get in trouble. Here,
This is the game.
let's just listen to these people.
Well, games, they kind of fake everything by using some statistical models. So it's not, you don't get reflections of everything in the scene. I think the
He's talking about
previous
ray
best that people could do was screen space, so you could only see reflection of stuff that was already on the screen. And so we've seen already some stuff actually in the
This
forget the
isn't
name
going
of
to
the
start
engine,
until
but
12:30.
the thing that powered Quantum Break.
So you're
and
with
they were
me for
starting to
12
do
minutes, you
proper
jerks.
Ray tracing, but it wasn't quite powerful enough to really do everything. And now with Nvidia RTX, apparently, I hear that they'll be able to do much more, get some much more realistic reflections.
On the internet.
I got to actually see the rigs that they were running the RTX stuff at GDC though, and it was using 4 like $15,000 graphics cards altogether for like a $60,000 rig. So I don't know if RTX is going to happen anytime soon, but it looks pretty awesome. They bill it as the future of gaming. Felix, thanks so much for talking to us and telling us a little bit about the tech. You guys, we're going to take a look back inside while we're waiting for this show to get on the road. So we're going to go check out the mood inside right now.
Oh, the mood. Oh, that's a good mood. That looks like a mood of some presentation. Looks like it's going to happen. I got some water at least. We're going to introduce some techno music. Timmy will dance for you, like I'm a puppet. Aw, shit's about to pop off. This is gonna be awesome. Yeah, here we go. What play your rig. Minecraft 4K, the Nvidia. Hi to Timmy Joe, reviews computers on the internet. Oh no, not the internet! Yes! Come on. The lights are dimming. Shit's about to pop off, my friends. 1963.
This technology. I want to incorporate this technology into my art and have the two mixed together.
CGI is born. Whoa! This is cool. Looks like the computers in Star Trek 1.
Where we thought things were going to be because we didn't have the compute power to support at the time what we wanted to do.
Larry Cuba. Oh, see, Star Wars. There we go. You know, you drop the bomb.
One day, a Bell Labs executive asked, what would it take to ray trace this scene in real time? And I said, well, we need a 512 by 512 array of Cray supercomputers, each with a red, green, and blue light bulb on top. And we'll put it in the desert and fly over it at 10,000 feet and take pictures of it.
What? Tron? I love Tron. I don't really love Tron. I'm just kidding. What's up, my friends? We're watching the event. This is going to be so fun. Can you hear it? Just want to make sure that you can hear it.
I recall it being sort of 10 or 12 months of hell getting these shots done, and it was because the render times were so horrendously long.
The T-1000. We definitely live in an awesome world of computer-generated shit. Like, it's Thanos.
One. Ready, go!
Virtua Fighter. Yes. Sega Saturn, my friends. Quake. They gotta run them so small because the resolution on them is shit. Oh, Half-Life, yeah! I'm excited about this now. Oh, the GeForce bubble. What's up, my friends? Oh man, I remember all these demos, downloading them so I could see how shit my computer was. Oh, World of Warcraft. Dude, 2004. Crisis. Finally, a card that'll run Crisis. Skyrim. Ooh, ha! Arkham Knight. Final Fantasy. Battlefield 5's not even out yet. Here we go. Jensen, bring out your leather coat. He's going to be leather coated so hard.
Please welcome Nvidia founder and CEO, Jensen Huang.
I always say Huang, which is, I guess, racist or something. He's got his leather coat.
Guten Tag, Gamescom. Welcome. First of all, great job, guys. We're going to kill it. Don't panic. Everything's going to be fine. There's so much technology in this room right now. It's barely under control.
There's at least 40,000
so you guys are going to have a great
smartphones.
show. Welcome to the launch of the GeForce GTX 1180.
There's no way.
I have never seen anything that leaked this much.
Well, iPhones, but that's a whole other thing.
The good news is you're going to be surprised. We didn't do it on purpose, but everything on the web, every spec is wrong.
Ooh.
You're going to be surprised. It's going to be a great show. This is a historic moment. This is a historic moment for computer graphics. For as long as there has been computer graphics, it has been the dream of computer scientists to generate with computers photorealistic images.
Pod champion.
When you look at this, what we consider the holy grail of computer graphics, you see some effects that today are simply impossible to create. First of all, light is coming in from the window. It's bouncing all over this room. The vast majority of this room is being illuminated indirectly. Whenever light touches a material, strikes a material, that material is rendered and simulated physically. The material is metallic or dielectric, is either smooth or rough. The roughness can come from microsurface structures.
I got some roughness
that bounces
for you,
light, absorbs light, diffuses light in a very different way. Maybe it's orientation dependent, maybe it's not.
It's like what you guys don't know is that I am being rendered
as a result, this entire
right
room
now.
looks alive. As light is bouncing around this entire room, it doesn't strike every surface the same way. Some of it is occluded from light. We call it ambient occlusion. You also see that there's a desk lamp, and it's shining through the glass, and because the glass has curvature and shape, light refracts around it and accumulates in a way that we call caustics. That little bright reflection on the table is particularly attractive. The shadow of phasma coming from all different directions. It's called umbra and penumbra. Umbra is where
Umbra
the
was
shadow
a
is
brand of soccer clothing I wore in the
occluded,
90s.
And penumbra is where it's partially occluded, and so you see the sense of soft shadows.
What's up, my friends? Oh, my hair.
She's
TJ's
reflected in the
rocking?
mirror. Even the parts that you don't
Thank
see.
you.
You know how mirrors work. You could see behind things.
Should have worn my
Oftentimes in
jacket.
video games, we can't do that. The little bit of shadow behind that painting,
Show the
ambient
thing
occlusion,
in the stream.
or as light travels through those gummy bears, bounces around inside the gelatin, and then reflects and refracts it back out, called subsurface scattering. All of those little tiny effects are really, really hard to do. And the good news is, in 1979, a computer scientist named Turner Whitted, now a researcher at Nvidia, described an algorithm that was both powerful and elegant. He called it multi-bounce recursive ray tracing. By starting from your eye instead of from a light source where light is emitted, because the vast majority of the light doesn't reach your eyes, so there's no reason to trace them. He traced light backwards, inverse ray tracing, through the eye, through the pixel, through every single pixel on the screen. The ray would seek out, would be sent forward, and if it were to strike a triangle, it would then send off a shadow ray to decide whether it's in shadow.
The shadow.
That shadow ray would go towards the light sources. If there's something else in the way, if it strikes another triangle, it would determine that it was in shadow. And if it doesn't, then it would accumulate the color and the intensity of that light would then be used to shade that surface.
Gotta get one of those microphones.
If that beam of light, if that ray going through
Like,
another pixel were to strike
Lewis,
a
what's his face?
reflective surface,
Wears all the time.
it would generate shadow rays to see if it's in shadow, and it would
Louis
also
Rossman?
generate a reflected wave, a reflected ray, a reflection ray. That reflection ray would be basically the same incident angle relative
good
to
one.
the normal of that surface where it struck. And then it would go off and decide whether it strikes another triangle, and if it were to strike another triangle, it would create shadow rays.
That's
it would
the leather jacket
determine
of the
whether that
fucking
particular
future, man. It's
surface
got
was in
some
shadow
stuff going on.
or reflection rays and such.
It
And if
sucks in
was
like
to
Marty McFly's.
To hit into a surface that is translucent, then it would generate refraction rays based upon Snell's law. And that this algorithm, this basic algorithm, would recursively run. And eventually, he would generate this beautiful image. In 1979, he generated this image. And it took 1.5 hours on a $1 million VAX computer. Basically, he was generating 60 pixels per second. Instead
Wow.
of 60 frames per second, he was generating 60 pixels per second. And so the question then is, how long would it take for us from that time for us to be able to realize this incredibly beautiful picture that I just showed you a second ago?
Until today.
If you look at our technology curve, has been nothing short of extraordinary. And ladies and gentlemen, you have so much to do with it. Because of the extraordinary demand of video games and the scale and the size and the vastness of this entire industry, it has propelled one of the most fast advancing technology in the history of computer science. If you look at this curve, Moore's law has been the foundational thought, the foundational idea of computer science for 35 years. And yet during this entire time, since our beginning, we have been moving at 10 times Moore's law. If you go back to when Moore's law was following historical levels of increasing performance 10 times every 5 years, 10 times every 5 years, or 100 times every 10 years. Our GPU technology was advancing at 1,000 times every 10 years. 1,000 times every 10 years. And so the question is, and by the way, these are some of my favorite GPUs. Look at GeForce 256, the world's first GeForce. How many of you had GeForce 256?
I only had a
Incredible,
GeForce 2.
thank you. Look how cute GeForce 256 is.
I don't even have
At the
a
time,
GeForce
so you know, at the
256
time,
now.
it was the single largest chip ever built. It was bigger than a CPU. And people were shocked that we built something that big, and they were even more shocked that we could sell something that big. But anyways, GeForce 256.
How's the
GeForce
chat
3 was
going?
the world's first programmable shader. GeForce GTX 8800
Bye,
was the
May.
first CUDA GPU, the most important GPU we had built.
Thanks for watching,
up to
guys.
that time. And then, of course, the most powerful GPU in the world today, the GTX 1080. Well, if you were to plot out this trend and you were to think about how many rays it would take, you had billions of rays we had to send into that room, even though we're not simulating most of the rays, only the ones that are coming into our eyes. We're sending in billions of rays into that room. We've got diffuse rays that we have to do. We have reflection rays, refraction rays, and it's bouncing all over the world, all over the scene. And you have hundreds of polygons, hundreds of millions of polygons. The amount of computation necessary is easily in the several petaflops. Well, several petaflops, we're already at the teraflops today. So it would take approximately 10 more years, at our current rate of progress to go from teraflops to petaflops.
He's going to pedophile us today, isn't
Well,
he?
we didn't want to wait that long. We didn't want to wait that long.
He's got petaflops for days.
And as you know, architecture is the single greatest lever in computer graphics. It is the single greatest lever of GPUs. So what are the interesting new ideas we could create that allows us to achieve effectively 1,000 times more performance 10 years earlier? And so we invented the Nvidia RTX. The Nvidia RTX is a platform consisting of architecture and software and SDKs and libraries that allows us to combine different types of rendering technology into one unified and cohesive platform. Of course, it should always take advantage of rasterization. Rasterization is so incredibly powerful and so incredibly efficient, but we also need to include ray tracing. However, just ray tracing at brute force level simply won't get us there. It simply won't get us there. And in fact, I'll show you something later that's just really amazing. It simply won't get us there unless we use this technology we discovered about 6-7 years ago called deep learning or artificial intelligence. We can finally create images along with ray tracing.
Did he have
that allows us
Skynet
to
make
achieve
the
levels
next
that
GTX
we
2080?
otherwise can't imagine. Now, we leverage two fundamental rendering technologies. You know very well rasterization, which is the way that we do things today. We start with the 3D world, and we take the 3D world information, the vertices, the triangles, and we project 3D world vertices into a 2D world pixel plane, into our screen space. That projection leaves the silhouette of a triangle. and we have to decide and test which one of the pixels are within that triangle. One of the most beautiful things about rasterization is that you could parallelize an enormous amount of calculation. And nothing is more beautiful than being able to do things in parallel. That's one of the reasons why the GPU is so incredibly powerful at parallel processing. It started with the idea of doing things in parallel. It also has the ability to do things incredibly high resolution, because high resolution is just more things in parallel. And so rasterization was incredibly powerful. One of its limitations, however, is that every single time you want to light the world, you have to project light from that light. And if you want 2 or 3 lights, that's fine. If you have an area light, that's effectively infinite number of lights. And if everything in the room were to reflect light, and everything in the room
like
became
a stormtrooper,
a lighting surface, otherwise known as
ones?
global illumination. In the world of global illumination, all of a sudden the number of lights that you would have to cast inside that scene is just insane, and therefore undoable. Well, this is where ray tracing is particularly effective, because ray tracing, using Turner-Whittett's approach, simply traces the number of pixels that comes into your eyes, the number of rays that ultimately reach your eyes. The vast majority of the rays inside this room, the vast majority of rays in the world simply never are reaching our eyes. And so we immediately reject them. We immediately don't have to do them. And we start from ray tracing our eyes. Ray tracing, whereas rasterization is taking 3D world data, projecting it in 2D, ray tracing is sending out a ray of light, intersecting the pixel at the screen space, and enters into the world looking for a triangle that it would intersect.
There's a lot of people out there
The two
going,
basic approaches,
okay,
both has its strengths and weaknesses.
I don't care about it. I just want it in my
to ray trace
computer.
this entire room, the number of rays, the trillions of rays, the hundreds of millions of polygons, the amount of testing that you have to do just to figure out which ray intersected which polygon is just extraordinary.
There's
you
tons of
simply
rays.
can't do it.
The
Well,
famous original rays.
we put this platform together. We put this platform together, and we worked with Microsoft to create the DirectX ray tracing, otherwise known as DXR, the Microsoft DXR. And then we worked with Epic to integrate RTX
directly
DXR
into Fortnite,
into the Unreal Engine, the UE4 engine.
Kinda.
And we found somebody with extraordinary art assets, Industrial Light and Magic, and together we created the world's first real-time ray tracing demonstration. It had never been done before. And we announced it this year at GDC, and I think it's worthwhile to take a look at it, and I want to show you something special about it in just a second. Okay, so this is
Stormtrooper number 1. Cool.
What's the story with all the elevators lately? I heard Kylo Ren destroyed the one over in D sector. If you ask me, who's ever in charge of this place should be transferred to Hoth. What?
Uh-oh.
What? You think she heard us? Yeah, I think she heard us. At least we blend in for once.
Incredible, right? Absolutely incredible.
But you gotta have one of these gold
And so
Nvidia
what
boxes.
what you saw was physically based materials. It was sitting in an elevator shaft where there were area lights, and those area lights were moving as the elevator was moving. And therefore, as the area lights would illuminate the surfaces, and the shadows would be soft. The shadows would be soft. Using area lights is incredibly difficult to render shadows. And notice the inner reflection. There's reflection off of Phasma. There's inner reflection of Phasma on her gun. And there's reflection of of her gun on her chest. And if you look at the stormtroopers, the illumination and reflections are all completely in real time. Doing this is simply impractical today. The way that you would do it, of course, is that you would fake a whole bunch of lights. That would slow down performance. It still won't look right, and all the shadows will look bandy. Second, you would create all kinds of what is called reflection probes made out of cube maps, but unfortunately, they're all moving. So every single scene, you're going to have to create a whole bunch more reflection probes, a whole bunch more cube maps, basically starting from the point where you would like to have to see reflection and rendering out from that point every single direction, turning into a cube reflection map. Those tricks simply are not practical with a scene of this level of fidelity. Well, it took 4 Tesla V100s, the same GPUs that are powering the world, 5 of the world's top 7 supercomputers today. It takes 4 of them in a $68,000 deep learning supercomputer that we make called the DGX. This is what researchers use to create their deep learning AI models. And so $68,000 to finally render running the RTX
That's the price of a brand new
real-time
Tesla.
ray tracing at about 20 some odd frames per second. Well, when we announced it, people got so excited about it. They said, how do we buy that DGX? We could use it as a game console.
$70,000
And the
game
requests just kept coming in. How do we turn DGX into a game console? The price point is slightly out of reach for most gamers.
Slightly.
And so today, I would like to make my first announcement.
They're putting
Starting
them on
immediately,
sale.
DGX.
That's a lot of payments of $19.99. Jensen's got jokes today.
3,000 easy payments of $19.95. 3,000 easy payments. We'll throw in the first game for free. So call now. The telephone number is right below you. 1-889-789-2080. And good luck with that. It's beautiful, isn't it? That's just completely liquid cooled. It is silent, doesn't make a peep, and it does real-time ray tracing.
It's not a real phone number, Jensen.
$68,000. Well, it turns out what you were looking at just now was not running on that. It was running on this little thing, this little bad guy.
Oh,
this is
that bad
called
guy.
Turing. We've been working on Turing now for almost 10 years.
Duh,
Trying,
10
failing,
years?
trying, failing,
Hit it
trying,
this whole
failing, all
time?
these different algorithms, trying, failing, and finally, Turing. The most advanced GPU we've ever done, 10 years in the making, the greatest leap since we created CUDA, and computer graphics will never be the same again. Inside Turing is 18.9 billion transistors. This GPU, this chip, is the second largest chip the world has ever made. The only other largest chip is called the V100, which powers supercomputers all over the world. It has 3 brand new processors. The SM is completely brand new, has the ability to do independent floating point and integer operations. And the reason for that is sometimes you're shading for color, sometimes you're using integer operations to calculate addresses so that you could run your shader program to do things like subsurface scattering. And as more and more special effects are to happen, the SM's address calculation part of the logic becomes much more complex. 14 teraflops and 14 integer operations per second. I like to shorten it just to 14 tips. So 14 teraflops and 14 tips. It also has the ability to do this thing I won't talk much about today, but we're going to write plenty about it, variable rate shading, so that we could do things like foveated rendering, focusing all of the horsepower of the GPU where your eyes are focused instead of wasting it evenly across the entire space. If you're moving, we might be able to adapt the place where we focus your shading horsepower. If the resolution or the content detail is different across the entire scene, as most scenes are, we could focus our horsepower where there's the greatest amount of fidelity. As a result, you're effectively getting a several X boost in your shading performance. The second is a processor we call the RT core. RT stands for Ray Tracing Core. It's 10 gigaраys per second. I love saying that, 10 gigaраys per second. A 1080 Ti, the fastest GPU in the world today,
keep saying
1080 Ti does 1.21 you guys got, no? Nobody ever saw that show? 1.21 gigaраys per second, okay? And so we do 10 gigaраys per second, which is 10 times a 1080 Ti. Wow. It does I'll explain that in just a second, a BVH traversal, tree traversal, and it does ray triangle intersection testing.
Not ray triangle intersect testing!
Which runs AI processing like crazy. 110 floating point teraflops, or because it has multiple precisions, depending on the type of networks you're running, you might be able to use lower precision or mixed precision. As a result, 440 tops with 4-bit integer. All of this so that we could do hybrid rendering and run RTX. Well, so the question is, how does this all turn out? So if you look at the performance, it looks kind of like this. So Turing is built for RTX. And if we ran, the first thing I showed you was originally ran a GDC was DGX with 4 volts, 55 milliseconds. 55 milliseconds, about 20 frames per second. And this is what Turing looks like. 1 Turing. So 4 volts in a DGX.
Really?
This has never happened before.
It's like, what was the point of
this? Has simply never happened before.
I guess it's not
doing
meant
computer
for
graphics.
This stuff, but
essentially a supercomputer replaced by 1 GPU within 1 generation. Of course, it took us 10 years working in parallel. If you were to look at Pascal, this is what Pascal looks like.
What?
The fastest GPU on the planet. The fastest GPU on the planet today. 1080 Ti, 308 milliseconds versus 45. Basically, about 8x. So the question is, what's happening under the hood? This is a new computing model, and so there's a new way to think about performance. It's a new computing model, so there needs to be new metrics. Back in the good old days, the vast majority of computation was done in shading. We're basically shading the color, or we're running a program in the shader, and basically we're shading. But in the future, we're going to be doing lighting, we're going to be doing all kinds of image processing.
Real time.
And so the pipeline is completely different. And if a pipeline is different, the platform software's got to be different, the architecture of the GPU has to be different, and you have to measure it differently. We have a new way of measuring. And let me talk to you about how we're going to do that. So if you look at this frame, this is abstracted, of course, but it's not too far off. Basically, within the frame that I was showing you earlier, we're doing ray tracing pretty much all the time. Okay, we're shooting rays all over the place. We're looking for intersections of triangles and figuring out which one of them has to generate shadow rays and which one of them have to generate reflection rays and which one of them has to generate refraction rays. And for the reflective rays, it's got to figure out how many more shadow rays it's got to generate. And so all those rays are being bouncing all over the place, and eventually we accumulate the color, the intensity, whether it's directly or from something nearby, and we shade that surface. And so we're ray tracing all the time. And that's with our RT core. That's the amount of time, the fraction of time within 22 milliseconds that an RT core is doing it. Imagine if we didn't have the RT core, multiply that by 10. If we didn't have an RT core, that green bar, just simply in terms of time, is just 10 times larger. So basically, all the way down the street. Shading is shading. We're doing shading incredibly well. One of the things that's really great about
I'm just wondering what this actually is going to do
is that we can now
FPS,
overlap
like,
or run independently.
Yeah, it's going to be able to ray
trace
trace this well,
call
but
it 1.5 times.
You know, if it's only like
more performant than it used to be.
Better performance over the 1080
and
Ti.
Then that's the
in standard stuff we're running now.
And then for DNN processing, when everything is done, we could use it to generate pixels that we haven't finished. To generate using artificial intelligence the pixel that we haven't finished, or use artificial intelligence to generate resolution that we otherwise couldn't have. Okay? It is possible to filter information, but it's very, very difficult to generate new information that looks right. And so with artificial intelligence, we can now, for the very first time, generate missing pixels that are actually right. And we could do it in real time because we have the tensor core. And so if this is what's going on in the frame, then what's happening inside our chip? So the first part of that processing, the shader and the RT core, the Turing SM and the RT core are both concurrently running. Later on, we're shading and running other parts of the program, the shader program. And so those two parts are running, the FP and the integer. And then finally, when everything is done, we're going to use artificial intelligence. All of our 110 teraflops, 110 teraflops, think of that, is basically 10 1080 Ti's. It's basically 10 1080 Ti's dedicated to doing one thing, which is artificial intelligence. And so if you just simply do the math, you have about 14 teraflops of shader math. You have 110 teraflops effectively.
AMD is never going to catch this.
Ray tracing. 14 plus 14 independent teraflops and TIPS. And then lastly, 110 FP16 tensor core processing floating point operations per second. When you take that and do the weighted average on it, it's basically 78 tera RTX ops per second.
He's just
and so the way to think about performance in the future is to figure out a way to weight all of these different types of processors. And so the way we think about Turing is 78.
Just the tip.
78T, 78 tera.
What's up, Golden Gamer?
RTX ops. Okay? Compare that to a Titan X, our highest end of approximately 12. 78 versus 12. When you're running ray tracing, that's what it's going to look like, 78 versus 12. Well, one of the most important miracles, you're going to see a lot of writing about this in the future, is simply the testing. The concept is simple. You're sending an array into the scene, and you're trying to figure out which one of those triangles out of 100 million that intersects. Well, you could simply just walk across the screen and see which one you eventually touch. Well, you got to go 100 million times. Or what you could do is you create a data structure, an acceleration data structure called a bounding volume hierarchy. Basically, it's like binning. Suppose I had 10 things I got to figure out which one is the one I want. I was asked to go pick something out. I had to go pick one of 1,000. I'm going to put 10 bins or 10 boxes, and within each one of them, I'll have 100 things. Within each box, I'll have 10 boxes with 10 things each. If I knew that, if I started looking for that
you guys
thing
following this?
Out of those boxes, and I discovered that it is in one
There's a box
of those
chocolate
larger
Easter
boxes,
bunny somewhere,
then I
and
can
the new RTX
ignore every other box.
Will find it for you.
And then once I find it within the larger boxes, if I find it within one of the 10 smaller boxes, I can ignore all of the other boxes. And then if I can find it within that box, I know it's one of the 10. It's the same idea here. We're sending this triangle, we're sending out this ray, we're trying to figure out which one of the triangles it intersects with. And once it intersects with a bounding box, which is a large structure, which has a whole bunch of other bounding boxes within it, which other boxes within it, and within that there's a whole bunch of triangles. Once we intersect one of the bounding boxes, we know all the other bounding boxes are ignored. And then we figure out which one of the bounding boxes within, and then once we figure out which one of the bounding boxes within, we have to figure out which one of the triangles it happens to be. The amount of mathematics necessary to do this is just shocking. And to do it precisely so that the image quality is
That's
perfect.
kind of where I was getting Golden
really
Gamer.
hard.
I kind of figured that
took us 10
he's
years
going a
to
little
do this.
too far with how
To
this is
create
explained,
the
but
architecture and the algorithm
if
for
it's
doing this,
that
design it
crazy,
in
I
a
guess
way
it
that
needs
actually
that kind
speeds
of
up, which is
introduction.
very, very hard to do because these beams, all these rays are incoherent, which is the enemy of parallelism. Somehow we
Wouldn't
figured
you
out
just
a way
hate
to
to go
make
on a
all these
date with
incoherent
Jensen?
things
He would just
largely
talk
parallel,
like this the whole
and then
time.
to create an
He was
acceleration
like, "When am I
structure, an
fucking getting the check?"
accelerator that allows us to do this
We ate
at the
10
speed
chocolate
of light.
bunnies with boxes
And
on
so
them.
The RT core was invented.
I'm excited about the core,
RT
dude. Let's
core
make it happen.
invention had to go along with all the software layer on top of it and what we call eventually the RTX platform. At SIGGRAPH, we were really pleased to see research being done in this area. Our researchers and the researchers at the Search for Extraordinary Experience, I love that, SEED, Electronic Arts research team. NVIDIA research is called NVIDIA Research. EA research is called SEED. I love that. The Search for Extraordinary Experience Division. And so they worked on RTX with our researchers to figure out how it could accelerate, how it could create new computer graphics.
You guys could have just
and
came back
everything
later
from
and I'll just
deferred shading,
talk
and
with the picture of it
direct
holding the
shadows and
card
lighting and
and
reflections
tell you
and
what
global
the specs
illumination
are.
and ambient occlusion,
Man, this is taking
transparency and
forever.
translucency. Translucency and transparency are just incredibly hard to do with rasterization because the concept of depth is very difficult to discern. And post-processing, as you could see, for each one of these operations, we're using different parts of the chip exactly as I
like how they're
described
not showing
earlier.
the slides to the
The
Twitch stream.
effective ops, the effective computational capability, 6 times Volta. 6 times Volta, 6 times NVIDIA V100. And so that kind of puts it in perspective. This new Turing processor, this new Turing GPU is just a monster. It's incredible. Let's take a look at some of this stuff. And so this is what it looks like. This is computer graphics today.
That's
physically based material,
not a
direct
graphics
lighting.
card, that's
You can see the
balls.
shadows. They're hard shadows. We could try to trick it by blurring it a little bit, but it's still going to be basically that. And this is what RTX looks like. Okay, so
The Christmas balls came alive. I guess that looks pretty cool. The crowd is livid.
hey, you got to clap at the old stuff too because it resembles us. So
Yeah, I
here we
got
go. I'll give you a
big
chance,
green
guys.
balls in my.
This is where we
Like
came
my
from. You got to be
balls.
proud of it. You got to own it. It's ugly, but you got to
Those
own it.
graphics are balls. Ray
Before-
trace my balls.
After. Before RTX, after RTX. Oh no, this is just the beginning. I'm just warming you guys up. I just gave you an olive for the appetizer. Okay, can we show them some stuff? Nacho, is it you and me?
Yes.
Okay, so this is Nacho. He's one of our dev techs, incredible computer scientist, amazing computer graphics engineer. This is what he was able to do with RTX off. RTX off. Now, of course, this scene is incredibly hard, and the reason for that is because you can't use tricks like screen space reflection here. You could put some reflection probes, but it's just incredibly hard here because things are being reflected all over the place. There's refraction. You see that graphics card back there? That's a beautiful graphics card. I announced it a week ago. That's called the Quadro RTX. And you got this crystal ball here where it should reflect and refract.
And it's
There's
not.
a little green ball on the ground there. And then there's that chrome ball in the back and this empty, I don't know why, but empty glass box. And it's got area light coming in, which is really hard to do. Okay? And so in this particular case, Ignacio is doing his best to emulate the area lights, but the shadows are ugly. you know, this is the limits of today's computer graphics. Now, we could fake a lot of stuff. We could fake a lot of stuff by arting it up and cause you to not look at it. But in the final analysis, this is what the limits of today's computer graphics is. Now, Ignacio, let's turn RTX on.
Oh.
So let's take a look at RTX on. Look what happens. The refraction of the glass globe there is just incredible. And look at this, the little caustics on the ground. The area lights cast a soft shadow. The umbra and the penumbra, notice of the graphics card.
What is he talking about right now?
The shadow of the chrome ball looks right. Now there's reflection of the glass box in the RTX, Quadro RTX. You see Quadro RTX from that sphere, and you see the reflection of the chrome ball with a little bit of rough surface to give you a sense of material. Everything just kind of looks right. Even the glass is casting a shadow. Even the glass is casting a shadow. Hey, let's go back to the last one again.
Looks so gross.
Yeah, I know. Now, of course, we got to add a whole bunch of paint and a whole bunch of stuff to make it look right.
You got to put it in Microsoft Paint.
Way. RTX on.
Looks so good.
And there was a gasp in the audience. But this could possibly be a photograph, right? Nacho, show me what you got. Oh, come on. Okay. Pretty incredible. Oh, you had to turn on a spotlight on top of that. Everything just works. Everything just works. Look, glass reflects and refracts and magnifies just like it's supposed to. And you just have to turn it on. And so the benefit of RTX is just turn it on. Thank you. Good job. And so now I'm going to show you something. We're going to turn it all together. We're going to put it all in. We're going to put it all together.
All right, let's watch it.
And it's going to be a demonstration that we created recently. To highlight the power of NVIDIA RTX, this mixed mode rendering, unifying rasterization, ray tracing, compute, and artificial intelligence. And what you're about to see is completely in real time. Everything you're about to see is completely in real time. It's kind of hard to grok because it's going to be so beautiful, but it's completely in real time. You're going to see beautiful reflections. You're going to see inter-reflections, reflections of reflections, and it's all going to be dynamic. You're going to see beautiful lighting. You're going to see area lights. You're going to see beautiful ambient occlusion. You're going to see beautiful physically modeled materials. So things that look like metal looks like metal. Things that look like things look like things. That's very technical. And that's how I talk to the engineers. Guys, we got to make things that are things look like things. And they go, I know what you want, boss.
Yeah. They bring them a new leather jacket.
And so what's in here is just really a miracle. And it's running on one Turing GPU. It's running on one Turing GPU. Ladies and gentlemen, the name of our demo is called Sol, S-O-L.
It's called Ligma. Let's check this demo out. All right, we got a spaceship, some sort of rocket ship. This looks pretty cool, though. RTX. Still haven't named it. Not a rocket ship. Mass Effect? Oh man. That's pretty cool. the laser was being reflected all weird, like it would be in real life. He's putting on an Iron Man suit, or a suit that'll just like let him play really awesome badminton. Oh, he's gonna dance, isn't he? He is gonna dance. Called it. I think they've showed this before, that's why I knew that. Where is the cake? There is no cake. The cake is a lie. That reflection. Oh, he's gonna dance. Okay.
What do you guys think? The Nvidia RTX. Nvidia RTX running on top of a Turing GPU. Hybrid rendering, real-time ray tracing for the very first time.
Would have been way more impressive had he had
the
that
first
computer on stage.
Deep learning is the single most powerful computer technology that has come onto the scene in the last 30 years. Deep learning is a field of machine learning where using a large amount of data, you could train a supremely large neural network how to do things.
Almost got 301
you
in the
train these
freaking
neural networks
stream.
with all of this massive amounts of data, which is otherwise examples on supercomputers. And this is the reason why voice recognition, natural language understanding, photo tagging, image recognition, all of these amazing feats of software are now finally possible. It is the reason why self-driving cars is even within reason to fathom. Deep learning is changing one industry after another. And people consider this the fourth industrial revolution. It is going to enable AI and computers to write software by itself.
That allows them to be
basically run on a
above and beyond
to
what
write
we
software
program
by
them
itself.
for. And
At NVIDIA, we're doing all kinds of research around deep learning. We have a gigantic supercomputer that all of our researchers use to develop software. Now, some of the things that are, I'm showing you some examples here. These are some of my favorites, but there's so many. For example, you could teach a neural network how to colorize by just showing this neural network examples of, this is a black and white, this is how you colorize it, this is black and white, this is how you colorize it. It eventually learns what the pattern is, and you can give it a black and white image, and it colorizes it. You could teach a network how to take a low resolution image and make it higher resolution. Because you and I could look at this image and say to ourselves, you know what, I bet I know what pixel each one of those pixels are. And so you could use a low resolution image input and eventually get an output of a high resolution image by going the other way, which is starting with a high resolution image and give this neural network the opportunity to generate that, and whenever it's wrong,
talked about this stuff.
Whenever it's
and now we got to talk about deep learning again.
Correct it.
When all we want to do
called
is
stochastic
see what
gradient
crisis
descent and back propagation.
Oh,
and so you literally correct it, and it tries to guess and guess and guess, and it corrects itself until one day it's able to figure out what pixels to generate. You could teach it how to take a cartoon and turn it into live video. This is a piece of work that we did in NVIDIA research. Okay, we simply taught it how to do that. Pretty amazing, right?
My 2080
we
just
could
arrived.
teach it to take a low resolution CT scan.
I'm just kidding.
And not only increase the resolution of it, but also segment it. Figure out what organ is what from that blurry blue image. Okay, you watch this. We taught it how to segment, how to identify which organ is what, and put a different color around it.
Whoa. I guess that's pretty cool.
Pretty amazing. This is going to revolutionize medical imaging. We have a platform called Clara. It has the ability, you could teach it how to go find identical twins.
What?
Come on, you guys, that was funny.
Colorizing hair?
This is what we taught it
That's
to do.
That's not funny.
Change the color of the hair. All in real time.
Oh, yeah. Now my wife can not make the mistake. She could just load up the app and be like, oh, that would look terrible with that hair. Blonde.
Much harder. Now you could do it with an artificial intelligence network. You could take a sketch and turn it into 3D.
What?
So you take this neural network, you give it a whole bunch of examples, you tell it what is the input and what is the exact expected output, and we give it a chance to try and try and try and try again, trillions and trillions of times on a supercomputer. Eventually, it trains and does this amazing thing. And then it creates this neural network model with hundreds of millions of parameters or hundreds of gigaflops of operation necessary to perform its task, to either classify, to predict, to draw, to generate, to imagine what color looks like. We could teach it to do these amazing things.
He really hates that gamers.
However, there are so many architectures, and it takes so much processing to do it in real time. And so we created this thing called a tensor core. There are a whole bunch of them in our chip. And imagine this, okay? Imagine that a 1080 Ti is 1080 Ti is what, 11 teraflops. A full 1080 Ti, a full 1080 Ti at $699 is 11 teraflops.
Is that how much they are right
now? This is 110 teraflops.
I doubt it.
Basically, it would take 10 full 1080 Ti's to keep up with the tensor core processor that's all over the Turing GPU. Now, one of the things that we taught it to do is something really incredible.
Oh my God!
And so we taught the neural network this thing, and we're calling it the Nvidia DLSS, Deep Learning Super Sample. Basically works like this. We create a whole bunch of super high resolution images with lots and lots of samples. So we jitter it, and we create basically 64 amazing images, and we create hundreds of thousands of those. And then we give our network, we put an image in here, and we say, using this, it's called an autoencoder, convolutional autoencoder. It has to be temporally stable because we want to do this for live action. And so the network has to remember part of the past. And we're going to give it an image, and we're saying, go generate this amazing image on the output. Okay? So pretty soon we'll be able to give it a new image it's never seen. We train it, and every time we train it, if it guesses wrong, we tell it what's the right answer, we propagate it back. It takes another image, it guesses it again, and if it turns out to be wrong, we propagate it back. And we sit there and we just simply loop on it on a supercomputer. We run it trillions of times. And then eventually you put in an image, and it creates this beautiful image out. You create you take an image,
Anybody
of
know
lower
what he's talking
resolution,
about
say
right now?
1440p, and it creates this beautiful image that's 4K. Now, of course, the question is, where did the images come from? Where did that come from? Where did that magic come from? It came from partly a supercomputer. Essentially, what deep learning is doing is codifying the memories of a supercomputer, and it puts it into this neural network, basically an image generation brain. And you put this image generation brain, this neural brain, into the mathematics of our GPU. All of a sudden, it knows when it sees this image, a better version of it is that. And it sees a new image, a better version of it is that. That mathematics came about, the weights of those neurons came about because of a supercomputer. And so in the future, every game would have had the benefit of supercomputer pre-processing before you play it. And we call that platform the Nvidia NGX.
Oh, God. Stream! Where's the stream? Too many people are watching. I was loading too many pictures of Reboot. Oh, God. I'm going to lose all y'all.
All kinds of amazing image processing. You saw earlier super resolution. We've invented super slow-mo. We're going to do all kinds of amazing things that makes video games and the images that come out of these computer graphics, CGI, look even more amazing. Basically, it works like this. We have a supercomputing infrastructure. There's a whole bunch of software that runs on it. The first thing you do is you generate ground truth. What is the perfect image? What is the perfect image? And then we have to train this model. It's a multi-dimensional manifold, and we're basically randomly walking around this manifold looking for the least error, looking for the time when you send in an image, the output is closest, your predicted output is closest to what ground truth is, okay? That your prediction is the closest to ground truth. And you're sitting here wandering around this gigantic universe, and it's incredibly, incredibly large. And so the computation time is very, very long. And that's why we build these supercomputers we call DGX. I showed you earlier version, the desk side version with 4 GPUs. These ones have 8. And then we test and optimize it. Then you put in a low resolution image or lower quality image, or the image is in fact not even complete with ray tracing, and somehow we complete it. Somehow we make it more beautiful. The Nvidia NGX. And then we have this AI model that we then OTA to you. You download it into your driver, into this plug-in interface called NGX, and the neural networks are changing all the time. They're getting better and better, and we put it up in the cloud, and you could decide whether you want to enhance your images or not. Then you run that on Turing. NGX, driver, this is all part of the RTX platform, and you run it on the chip.
So we get
the supercomputer looks like this.
1080 Ti.
This is the machine that is generating all of those networks.
Look better, like
and
Instagram?
Basically, before you even run it on Turing, before you even run your game on Turing, there are a bunch of supercomputers. Here's one.
Oh,
there's a bunch of supercomputers that's training these models, and the graphics card. Here's one.
Oh, are you gonna finally show it, you bastard?
The graphics card.
Oh, that's not.
You guys know what a graphics card looks like, right?
Here's
one.
Jokester.
Available retail, $68,000.
I'll enhance your private images there, the grand.
Okay. Got to keep your abs tight while you're doing this. A whole bunch of interconnects, SerDes interconnects called NVLink, connects all of these GPUs together into one virtual GPU. Every single GPU can see each other's GPU memory. All together, this board, that system has 2 of these inside. 2 of them. This is 1 petaflops. That's another petaflop, not motherboard, but mother of, God, it's heavy. GPU. 2 graphics cards.
Know what it's called.
Makes 2 petaflops. 2 petaflops. You want to put 2 petaflops is basically a supercomputer with servers from that side to that side. 400 servers. $2 million without anything else of servers. This replaces. And so we use this to train the neural network model. Here we go. Here. You could do it.
If he dropped it, oh man, I would have shit.
You use that, and you train this network called the Nvidia DLSS, okay? And then it comes up with a model like this, and this is 4K TAA. You guys know the Unreal Engine Epic's demo called Infiltrator. It's just beautiful. Incredibly taxing on systems, and 4K TAA up there. TAA is the anti-aliasing technology we invented, which is temporal. And so temporal, it takes last frame, the motion vectors, and it tries to figure out what's the best combination to create beautiful edges. Look at that, because it's temporal and the motion vectors, so many things are moving. You see a disjointed hinge over here. And this is 4K DLSS. Look at this.
Doesn't really help if you're not
That's just
showing
perfect.
the Twitch stream the proper
Okay.
resolution. It just looks like shit up there.
Well, for the very first time, because of this, because we could take a lower resolution image, and because we could train a neural network with all kinds of super high resolution and super high quality images, this neural network, if runs on a
Linus would have
bat
just
out of hell
dropped it
processor
and
called a
run it
tensor core,
on a test bench.
could
right
then
now.
in real time enhance images. In real time generate pixels it had never seen before. Generate pixels that make sense to go there, because if you and I were to look at it, we would know what makes sense to go there, and therefore it makes sense that we could teach a neural network how to make sense of what pixels to put there. So I'm going to show you something. This is Infiltrator running on one GPU at 78 frames per second in 4K at a quality that has never been seen before. A 1080 Ti, the fastest GPU in the world, can currently do about 30-something. Okay, from 30-something, what you're about to see is 4K. Now I'm going to lock it to 60 hertz because this display happens to be V-synced, and so you're going to see the frame rate on top.
The display behind
and
him
ideally,
is V-synced?
it's pretty high. Very first time.
It doesn't have
to see
G-sync?
Infiltrator
Like, what?
running at 60 hertz in 4K.
Such amazing quality on Twitch stream. Wait a minute, what's over there? Hello? I heard you. Oh, it's a shield. Forgot about this demo. Ooh. That's Deus Ex Mankind with dreadlocks. Deus Ex Predator Man Divided.
Is that amazing? It's just silky smooth. Silky smooth. One Turing GPU, twice the performance of the highest end GPU in the world today, 1080 Ti, running at 4K with beautiful image quality. Well, you know, we should probably at this point take a look at what Turing does and RTX does for games. You guys want to see some games?
Yeah.
Kata, what do you have for us? You need your mic on, sir.
Oh, testing 1, 2.
Yeah,
Okay. So,
ladies and gentlemen, Kata.
All right, so first up we have
Head of our developer relations. We work so closely with developers all around the world. We work with them to improve new technology, create new technology, and optimize their games for our platforms, and push the limits of what's possible in real-time computer graphics. And the work that we all do together is it just brings me so much joy. And we got this amazing developer relations teams that works with them, and dev tech team, and all these computer scientists that work with them. And man, it's just so great. I love you guys.
in my 17 years here, Jensen, our entire team has never been more excited over a new technology, a new product, than with Turing. And also with the developer reception has been phenomenal, and we're just so pumped. It's really an honor to be here to, deliver.
Kata, you know what?
Games.
I'm going to give every DevRel and every dev tech in our company a new Turing.
Oh my God. Oh, oh.
Oh. How about every Tim and Joe gets a free Turing? And every one of his subscribers.
I'm sure has increased by a factor of 10 since I said that. Okay, what's the first game we're going to talk about?
So Shadow of the Tomb Raider is the first up. It's the latest in the release, obviously.
Yay! This is
Not
awesome.
much needs to be said. It's a super successful franchise. Just data-wise, it sold 65 million units, and it's going to ship the Shadow of the Tomb Raider on September 14th. This
that
time,
when
the game has
console
Laura
version comes
Croft
out?
going on an epic adventure in Mesoamerica and South America. Just one thing to note, a parallel, Laura has a long and illustrious history. And actually, in many ways, Laura and Nvidia has grown up together because we both
Never thought of it that way.
Yeah, in the mid-90s.
Yeah.
And in fact, Jensen, it happens to be the first game I played when I bought my first Riva 128 in 19.
I was 30 when she was 25. Grew up together.
So yeah, so we work for Crystal Dynamics, Nixies, and IDOS Montreal, and we're excited to be able to show it.
And now what we're going to feature, we're going to show just a little part of it. Then later, there's an after show, and the developers are going to talk to you about all this. You're going to be able to see all this stuff. But we're going to show you just a few things about it. So one of the things, of course, Lara Croft, you're in shadow all the time. It's all about shadows. And one of the challenges with shadows, as you know, they're just using traditional shadows. They're too crisp. And so they have these hard shadows, and if we use contact hardening, and we use percentage closeness shadows, they're kind of blurry and fuzzy and noisy, and when you put a whole bunch of them together, it just becomes a big mess. And so what you're looking at is
the Mandela
ray trace
effect.
shadows. And you're going to see a lot of ray trace shadow stuff, and that's the first demo we're going to show you. We're going to feature ray trace shadows. Go, take it away, guys.
Hey. My name's
Chad.
Hey, I'm over here. And apparently I work in the DevRel team with Kata, and apparently I just got a new Turing, so I'm really excited.
Bingo.
So what we did is we worked with Nixies and IDOS Montreal to bring real-time ray-traced shadows to Shadow of the Tomb Raider. It's perfect.
And so the thing to look at right now with RTX off,
to
you saw
shadows
the crisp
of the
shadows up there, and you saw right here. This is really hard to do, and that's why they don't do it at all, which is dynamic lights and shadows.
These are dynamic point lights. They're really expensive to do in current rendering techniques because basically you have to cast shadows in every direction from the light. And this goes back to what you were saying earlier about having to put a cube map here and a cube map here, and every time you move, you have to redo all that rendering. So let's put RTX to the test and have it just do it for us.
Aww.
Did you notice the difference?
The beautiful thing about ray tracing is you turn it on. You know, when you turn on the light, it just does the right thing physically. And because we're tracing these rays physically, it should perform according to what we expect.
Yeah,
and so the umbras, where right behind, where it's nice and dark, it's correct, and where penumbra, where you have the softness of the shadow, because not all of the shadows are
that
occluded.
is pretty
Part of it is
cool.
lit.
There's a lot
you
of
get
different
some
shadows
softness.
moving in that.
Yeah. Off and on.
Wow.
Now let's take you to, you were talking about some of those area lights earlier. You want to look at some examples of those?
Yeah.
Well, here's a big example. This is an incredibly lit scene. This whole scene is amazing. It's beautiful. And so what we have here is we have two cone lights and two area lights. Those area lights are basically rectangular shapes, the neon lights above the stage. And what you notice is the shadows below are hard, like you keep talking. And this is state-of-the-art for real-time graphics right now. And I got to say that because the guys are sitting right next to me who made those shadows. And they are, Brett. This is the best we have.
Is RTX right
And
now?
they look beautiful.
Yeah, they look great.
Until now. And the way that's simulated, those area lights are simulated essentially as a couple of point lights. And that's why you see such hard shadows.
Exactly.
But if you simulate the area lights like area lights, because we ray traced it, and independent of where the rays bounced around, eventually, if it were to hit some part of that area light, it gets lit. And so ray tracing is a much more cost-effective, in fact, however, very difficult to do, way of doing area lights.
And let's turn this on and take a look. So you get the nice blend of the color and the light.
Isn't that beautiful, guys?
Guys, clap. Turn it off again.
It's rather.
And we can do whatever we like. We could add more area lights. We could add more spotlights. You can mix it all together without trying to fidget with it, without trying to figure out what is the definition of right. Right just looks right.
They're overselling this.
That's another wisdom. Right looks right.
And talking to the artists that do this, they tell me all great things about shadows. They're telling me shadow is another color to them. They love shadow. And they also told me that shadow and light is what they use to set the mood and tone of their environment.
That big a difference.
And so that's how important shadows
because
are.
I didn't
and it feels like we just gave them a lot more depth
the old way was. Doesn't look that much crazier to me. Like I get it.
More on.
There's soft shadows rather than hard shadows.
What you got?
Well, we want to take a look at some more area lights that are very interesting.
Let's take a look at one more shadow.
All right. One more shadow.
Ah! What the fuck?
That right there, that's the umbra.
Mm-hmm. You want me to turn it on?
Umbra. No, keep going. And that's the penumbra just now.
Okay.
Okay.
Twitch
that's
is
the
dying.
Penumbra. No, keep it off.
Too many people watching Jensen.
Yeah,
talk
see,
right
that's the umbra. And notice how sharp that is. That's just not right. It should fade away. Okay, turn it on. There you go.
Oh, wow.
There you go. Otherwise, it looks like another person on the ground. Look at that. The contact hardening just works. Leave it on. Contact hardening just works. The umbra works. The penumbra works. Everything just works. Okay. All right, man. Good job, Chad.
Thank
you. Chad. The Chad.
Guys, let's take a look at an exclusive trailer of the Shadow of the Tomb Raider.
Yes, Golden Gamer. Cool.
What is that?
Square Enix. This video game is developed not very far from me. Holy fuck, she's swimming in the lava. Oh, that looks awesome. Lara Croft, she can climb anything. Holy Christmas. It's gonna be a pretty sweet game. I always loved Tomb Raider. Falcon. Look at that thing. Shadow of the Tomb Raider.
That's awesome.
In a world. Oh man, what happened to my quality?
I can't wait. That's going to be a wonderful game. All right, what's up next?
Did the
well,
quality just
another
take a
blockbuster, and this time we have Metro Exodus by 4A Games.
Oh man.
Yeah.
Metro Exodus, that's cool.
So for those of you who don't know, it's the third in the Metro series. This is set to take place in 2036 in the post-apocalyptic wasteland of the former Russian Federation. You guys know this. It's been super successful. In just 2 versions of the game, they've sold 7 million units. And this one, Metro Exodus, is due out February 22nd of next year. It's going to be well worth the wait. It's developed by 4A Games, who since for the first time we met with them, Jensen, back in 2009, they're super enthusiastic and very forward-thinking, so we're not surprised that we have them here today to show something awesome.
Yeah, that's really cool. Now, the thing that we're going to showcase with this demo here
took his
is
jacket
something
off.
that is just really, really hard. Basically, the way light works is, can you guys see this? My light is really bright, but basically, light is coming in from the outside through those windows. And of course, this part is lit directly. And the challenge here is that's an area light, and so we have to make sure that the shadows look right. However, that light doesn't stop there. That light bounces around this room, and it illuminates different parts of the scene, depending on how close they are to
Really
that particular light, and maybe in the creases,
Well, you
and
have
the
to talk
corners,
your
it's
point.
really super dark,
Like, improve it.
but in other places it's more light, and direct light is completely bright. And so lighting this room using traditional computer graphics lighting is just incredibly hard. And this is the perfect showcase for global illumination. Now they want to use light, of course, to create these incredible moods. And so you feel, you know, a little scared when you walk into a room, instead of being completely black, which is not right, or completely lit, which is not right either. And so global illumination has the ability to create an aura, a feeling, a sensation that is really photoreal. And so this has been something that we've been pursuing literally for a long time. This is a 10-year pursuit that we have finally been able to do, global illumination. Let's take it away. So Matt, this is GI on. And so just as I was describing earlier, the light is coming in through the window. It's bouncing around inside, and as a result, we're lighting. Look at that. That corner is darker. That corner over there is completely dark, and that light right above the windshield is nicely lit. It does exactly what you expect it to do, and it does it all by itself. Just put sunlight outside. Super high intensity ambient light. Put it outside and everything just works. Everything just works. Now you could do it the other way. No, go to direct light. You see this? This is the way computer graphics basically works. Now, of course, we could create a whole bunch more fake lights. We can create a whole bunch more fake lights. But in this room, if you created more fake lights using spotlights, you'll get all these different areas that are lit too intensely and others that are not, and it looks like you basically turned on a whole bunch of lights. Now what you could do, and what Matt did earlier, is turn on basically a artificial global illumination light, which is basically a fake ambient light. It's like somebody comes in here, and instead of allowing us to light this room with global illumination, which is happening right now from these monitors, like for example, I'm being lit by the monitor, and you guys are all being lit by this screen, this 4K gigantic, beautiful screen. And so the entire room is being lit with indirect lighting. But here, because we can't do indirect lighting back in the past, as in yesterday, we had to put a fake light in here.
As in yesterday.
It's like somebody comes in here and put a fake light and constant intensity, constant color throughout this entire room. As a result, the places that should be dark, like back there, isn't dark. The places that should be more bright is the same intensity. Okay, which is what you're looking at now. So
Let me talk my way through why ray tracing
let's look
is
at right.
good. Let's look at it.
Look at that.
For 2 hours.
Delightful.
And then you can buy the graphics card. Yeah, that looks good, Jensen. We get it. You got really good lighting effects. You don't have to show it 20 times.
So Matt, our friends are now able to have like creepy monsters literally squatting in the corner.
Yeah. Take a look in the rafters in the ceiling. When RTX is on, they're black. I could hide anything in there. But if I'm lighting it ambiently, you can see everything up there. When we have RTX on, it's correct. There's no light up there, so we can actually hide things in. We can make the mood and the environment perfect by just letting the normal light in the room.
Games will never be the same.
No, sir.
So scary.
Monster.
All right, good job. Thank you. Let's take a look at another exclusive trailer, shall we? Metro.
Yes, Metro. It's an old church and a bugle boy and a deer that's really rotten. Jeep. You guys play the Metro games? Never have. Always meant to. Looks kind of scary. Looks more like a Resident Evil game. Did you see the light bouncing off of that
Wow.
monster's teeth?
That is incredibly scary. I don't think we have enough arrows. Okay, I'm going to flash through a couple of them, and then in the after show, we're going to show it to you. I want to save time for a whole bunch more stuff. Okay, let me show you. Assetto Corsa Competiziano.
I do like Assetto Corsa. It's a beautiful game.
That's Italian. I spoke 2 languages today already. Okay, when you guys see it later, I want you guys to look at some stuff. Okay, first of all, the reflection on the windshield. You guys know how screen space reflection works. If it's not on the screen, there's no way to take that image and reflect it onto the surface. And as a result, look at the glass on top. You see that car? You see the Ferrari up there? It's reflected on top. All of the rails all the way down are reflected.
Are any of
No
those cars
errors,
even
no
Ferraris?
weird banding, no weird distortions.
Is that a red one?
You see this guy reflected from the other side. So when you go see it, he'll be moving and everything will be dynamic. When the cars come through, you'll see all the reflections up and down this aisle of the cars with other cars, the cars over the window. Everything is going to be completely dynamic and nothing had to be tweaked. Ray traced reflections and ray traced inter-reflections. Cars are going to reflect each other. If you look at the railing, the shadows are just rendered beautifully, the soft shadows, because the world is one big area light. And shadow map precisions are just not good enough to go all the way down there. And yet, for ray tracing, it just works. In fact, if you see the final game, the other way, the shadows of the last buildings are completely gone. You're going to see reflections of the toolbox of the garage and the car in the garage. Everything just works. Global illumination just works. Ambient occlusion just works. All of the soft shadows underneath the cars just work. And you can look through the window, and depending on the angle of your view, you'll see Fresnel reflection. So sometimes you see perfect reflection. Sometimes you'll see through the car. Everything just works because ray tracing just works. You're going to see another game called Atomic Heart. And this game is just really interesting. And it's got wonderful reflections and refractions. And mirrors are curved. Curved mirrors. Nobody does that. It's impossible. Not for ray tracing. It just works. You get this area light underneath, casting that soft shadow for the robot behind it. Everything is physically based. All the materials are rendered beautifully. And so area lights, reflections of the scene that you can't see in the scene. So screen space just doesn't work. And yet everything just works here. Well, guys, I want to show you something that's really cool.
It better be the
You guys wanna see
fucking
an
video
amazing
card.
game? I can't wait for this. This is probably one of my family's favorite games, and this is wow, guys, I can't wait.
Everyone in his family, including his wife, plays Battlefield.
I think we have with us Jonas and Christian from DICE. Guys.
Okay.
Hello.
Some of the
picked up.
brightest, the most amazing computer graphics engineers in the world. We've been working together on implementing RTX into Battlefield 5. Now, you guys, the anticipation of Battlefield 5 is so great, I don't think I need to introduce what is the concept of Battlefield 5. It is a World War II FPS. It is part history, part travel, part time travel, part running for your life, part destruction, real-time destruction. You've never seen destruction like there is destruction. Isn't that right, guys?
Correct.
You guys know destruction.
We do.
You guys know
That's
how to
a lot of
blow
damage.
it up. Okay? There's mayhem. There's chaos. You work as a team. You can battle by yourself. I want to go learn all kinds of stuff about World War II by going through your game. I just want to be a tourist. turn on God mode and go through as a tourist. So we're going to show you some pretty amazing stuff. Isn't that right, guys?
That's
All
right.
Okay, Jonas, let's go. Take it away.
Yep, Christian. All right. Thank you, Jensen. Thank you, Nvidia, for hosting such a great show. This is really cool. I'm
great
Christian.
show.
I'm a tech director for Engine Group at
Some pretty
DICE.
sweet
And
eyeball
next to me, we
effects,
have
though.
Jonas, media and video editor. We're here to show you our implementation, our vision, our take on what RTX can be, and we want to show that in our brand new Battlefield 5. And in the setting, we'll take a look at our brand new multiplayer map, Rotterdam. And it's a really dense and cool city map. We'll start here in a very zoomed-in view of the soldier's eye. And we're going to observe something that we've never really been able to do before. So we at DICE have worked closely with Nvidia engineers over the past year to get to the point where we are now. And we're so proud and thrilled to be here and show it off to all of you. So Jonas, I'll leave it to you. Take it away.
Yeah. So what you're seeing there is a tank firing off screen, being reflected in the character's eye.
Oh.
Now, you guys know this is not possible with screen space reflection, right, Jonas?
Exactly. This is
because the fire is not on the screen.
So now if we turn around and we then see the environment, we can see that the tank muzzle flash not only reflects in the eye, reflects in the entire environment in the tram windows there and within the tank itself, moving here. So now if we keep moving forward,
It's pretty cool, I guess.
That's great. So of course, one of the big challenges of SSR is also complex surfaces like this. So now with RTX on, if we set off an explosion behind the tank here, but next to the car,
oh, come on,
reflecting accurately within the car.
Wow, come on. It just works.
That's impossible.
Of course.
How would you do that with RTX off?
Yeah, how does that look? Like this here. So let's,
Wow, that looks incredible.
And it's, of course, it's updating dynamically, everything.
Reflections will never be the same again. Look at the reflections off the ground, guys. It just.
Yeah, so you can see.
Wow, it just happens.
With SSR, if it's in the screen space, you still get some of the reflections upon the car, but due to the nature of SSR, it disappears as it goes away. But because ray tracing just works, you just get the expected result, how you'd think you'd see it. So the next thing we have to show you is the big, scary crocodile tank, the Churchill. And if we make that one shoot, it's flamethrower across the scene here. Then we will again see that reflecting upon the surface and on the soldiers battling it out here in Rotterdam. So now if we look down in the ground with RTX on, we'll see the flame, we'll see the soldiers moving, we'll see everything. And now if I turn RTX off, we lose everything. We lose all the detail, all the context of what's happening in the scene. But with RTX on, you just get a much more cohesive image and a better understanding of what's happening around you. So one thing we also pay particularly much attention to in Battlefield is just the weapons, accuracy, making sure the smallest detail is correct. And you can see even there, the flames are reflecting properly in the wood of this gun here and in the windows in the back. Now if I turn RTX off again, you lose all this detail. So yeah,
wow,
really cool.
Now
tech.
Jonas, what you guys have done is all of your guns, all of the objects are modeled physically.
Exactly.
It's physically based. And so the gun has wood, which is diffused, is a dielectric material. You have metal, which is reflective, and the metal has substructure in it, microstructure in it, so there's some roughness in it. And so without doing anything at all, because it's physically based, we shoot a ray into that scene. It intersects with a triangle on that piece of metal on the site, and it figures out, I need to boink, generate another reflection ray, and it traces its way to the flame, which is coming by, and when it comes by, it accumulates on the surface, it shades it perfectly all by itself. Ladies and gentlemen, the magic of ray tracing.
Exactly. And there's more. So What you see now are objects that are really close by, but ray tracing works for more yet. So up here, we've got two C-47 airplanes. They've been shot down. They're crashing with their engines on fire. So now if we go over to the car here, and you can also see the flame reflecting in the car nicely over there. So if we keep moving forward and then look down on this reflective car right here, we will still be able to see the plane. If we move back here, we can see the plane reflecting in the car. If I move this lens flare.
Wow, your lens flare works
right
good.
There, yeah. And then with RTX off,
I love it.
Everything other.
Yeah, look at that.
We can keep moving forward.
Wow. And Jonas, you guys did a great job with Fresnel reflection. Look when the angle is just right, it's just a perfect mirror. It looks beautiful.
So here it's a good example on transparent surfaces with Fresnel and PBR rendering. The more of an angle you're at, the stronger the reflection gets. And now with what we had before, on these ones were just cube maps, which they're also static, but with ray tracing you get a lot more detail. You see the entire environment. And of course, as I said, the old school cube maps, they are also static. So say that we were to destroy this building here, make a tank shoot it, with ray tracing on, you'll be able to see frostbites and Battlefield's destruction system within the window, moving dynamically. And now, to end it all off, RTX, I mean, it works on the entire scene. So what if we were to shoot off a V1 rocket here and zoom out, get a good view of the entire street of Rotterdam, and then take a look at the windows, all the places that you would expect to reflect. For now, turn up the time again, and we just wait patiently for the V1 to hit the ground. And there.
That's awesome.
That's great.
Good job, you guys. Good job. That's really great. And it's amazing what you guys did so fast. I know you guys worked super hard, but it's amazing how you guys implemented this stuff so fast. I mean, that's one of the benefits of ray tracing. You know, the benefits of ray tracing is because things are going to behave physically. You should be able to turn things on. If the rest of your system and your models are done properly, you could turn these effects on relatively easily. I mean, it still takes a great deal of great engineering, but comparing to doing it the traditional way of arting everything into existence, the amount of engineering that has to be done is just significantly lower going forward. You know, hopefully, using the laws of physics, when you guys create a scene, things would just look right and behave accordingly. And so this is really just such a great achievement. Wow, things are still falling apart.
Yeah.
I've never given a talk in total destruction before. You guys do destruction great. You're great at destruction. That's a lot of pent-up anger there, sir.
That's a lot of damage.
Lots of great destruction. Okay, you guys made an amazing trailer. Let's take a look at it.
Does look pretty sick. Looks like a pretty sick game. Battlefield B.
Wow, you guys killed it. You guys killed it. Real-time ray tracing. Battlefield 5. And we have a great surprise for you today. Battlefield 5. Open beta, September 6th.
Yay, now we can benchmark it.
Guys, congratulations on a great achievement. Yeah, this is really a wonderful achievement. Thank you. There are so many other RTX games coming your way.
Oh my God.
Developers all over the world are working hard on RTXing.
Thank you. Thank you. Finally. PUBG's
We're
gonna
gonna have
ray
all
tracing?
kinds of amazing games coming your way. Well, I guess your question is this.
We're gonna fucking
What are you
get
gonna
one.
run it on? What are you gonna run all these amazing games on? Well, let's show it to you.
Oh, finally! He's got a laser beam. Real-time ray tracing. Aw, two fans. Finally! Getting away from the bullshit blowers. Finally. Is a Thunderbolt out? No 2080 Ti game. So the renders were good. Cool. Woo!
Ladies and gentlemen,
he's got it in his fucking hand. Woo! He's got
10
balls
years in the
behind him.
making. The GeForce RTX 20 series. Computer graphics reinvented.
Ah, that looks pretty cool.
Isn't that beautiful?
That is pretty cool. That does not look like this.
The craftsmanship is unbelievable.
I'm happy about that.
The craftsmanship is unbelievable. This is the best design we have ever done.
No more.
Everything from the voltage, the power regulation, and the
Blowing out
thermal
the back.
management system. It is designed for overclocking. Crazy amounts of overclocking. Not to mention,
Yes.
it is just so quiet. Even when you're maximum overclocked. At maximum overclock, it sounds like 1/5 the audio levels as a 1080 Ti.
Well, no doubt.
It is so quiet. The engineering is just absolutely incredible.
I was just running my 1080 Ti now. I don't have a reference model. I have an MSI blower
three
model, though,
models
which
today.
is pretty much a reference model. And it's still pretty loud.
Announcing 3 models today.
But it's a lot less loud than like a 7970 or something like that. But that's pretty cool. So there is a 20.
The RTX 2070 with 6 gigaраys per second, 5 times that of a Titan X.
Wow.
5 times that of a Titan XP.
talking
45
about that,
trillion
but who gives a fuck
RTX
about
ops
the-
per second.
The ray tracing of it, if it doesn't
45
actually
trillion
perform
RTX
that much
ops
better
per
than the
second.
old one.
That is several times the performance of a Titan X. 8 gigabyte frame buffer. RTX 2080, 8 gigaраys per second, 60 trillion RTX ops, about 6 times the performance of a Titan X for ray tracing, 8 gigabytes, and then the RTX 2080 Ti, 10 gigaраys. I love gigarays.
Apparently.
10 gigarays. Shoot as many rays as you like. Go crazy. Just shoot rays. 78 trillion RTX ops, 11 gigabyte frame buffer. Starting at $499.
Really?
Starting at $499.
So the 2070 is $499.
Pre-orders today.
All right.
On shelf everywhere, September 20th.
Aww. I was hoping it would go, one of them would go on sale like next week.
And here is your Nvidia RTX family. The Nvidia RTX family. The Nvidia RTX family.
Can you say it one more fucking time?
The Nvidia RTX family.
He's
Ladies
stuck in a
and gentlemen,
feedback loop.
Soon, I'm going to see the Nvidia RTX family. The Nvidia RTX family. Quadro 8000. Quadro RTX 8000. 2 GPUs connected by NVLink, turning it into one large virtual GPUs. 96 gigabyte frame buffer. 166 trillion RTX operations.
So a grand for the 2080.
166. That
so
is
where does that put the
16 Titan X's?
The 1080 Ti, if the 2070 is better than the 1080 Ti,
$20,000.
which from all the bullshit he just pulled,
$20,000.
you'd think it would
Now just imagine, that is twice the ray tracing performance of a $68,000 DGX station. Twice the performance
RTX
of a $68,000 supercomputer. Then you have the GeForce RTX family. The 2080 Ti from $999. The 2080 from $699, and the 2070 from $499, and the 2070 is higher performance than the $1,200 Titan XP.
Really? That's good shit. That is what we deserve, finally.
Look at it this way. I want you to look at it this way.
I want you to put that video card in a computer and run.
This is what they look like.
Strike. Really?
The biggest generational leap in the history of computer graphics. Our beloved Pascal, the best GPU the world had ever seen, next to the Turing family. It is a shocking contrast.
You guys notice, I turned Jensen down. You guys notice that he hasn't actually said anything about the real world performance of this, just the ray tracing performance? That's bugging me.
The GeForce RTX, the first.
All he's saying is that it ray traces
platform
better than like the 1070 or the 2070, better than a 1080 or the
rendering
Titan
mode
XP.
Of rasterization and ray
it's not
tracing.
saying that the actual frames will be better.
CUDA and artificial intelligence. Artificial intelligence that was trained using supercomputers. And all of those neurons and all of those weights from all of that experience then sits inside your PC. And it generates images that no possible software written by humans could do. And it generates beautiful images. The Turing, the largest generational leap in the history of our company.
That's what I'm saying, guys.
The most important new GPU we've created in 10 years since CUDA. 78 tera RTX ops, 78 trillion ops, basically changing things so dramatically, we have to change the way that we talk about performance. Because in the future, you're going to ray trace parts of the image, you're going to rasterize parts of the image, you're going to use post-processing on some of the image, and you're going to use artificial intelligence to generate all kinds of pixels that are impossible to generate otherwise. And the GeForce 20, the GeForce RTX 20 series, starting at $499, available everywhere on September 20th. What do you guys think?
Woo! He hasn't said one single word about its mining performance.
Okay.
There'll be a 2060
I have
later on, I'm sure.
One more surprise for you. The guys did something. Well,
I'm hungry. I want to go eat lunch.
Real time. It's physically based. All the materials are modeled properly. Reflections just work. Inner reflections just work. The lighting just works. Ambient occlusion just works. Area lights just works. Have I told you that before?
Yes.
Lighting, reflections, shadows, it just
I wonder how
works.
Much that golf
Everything
shirt
could
cost.
be dynamic. No
That's probably
cooking
a $10,000
no
golf
art
shirt.
necessary. Just turn on the lights. Enormous amount of computer graphics capability then kicks in and draws the rest of it. Everything you see here is all completely in real time. Ladies and gentlemen, have a great Gamescom. It's been a pleasure being with you.
If it's in real time, how come you couldn't have the computer on the stage?
Has been reinvented.
Thank
you very much.
this thing again. Yeah. So what did you guys think about it? Personally, he's talked a lot about ray tracing, and I get that that's going to be a really cool technology, but it didn't actually look that much cooler than the standard way of doing things until the Battlefield demo. I thought that was really cool. They had the Battlefield, the explosions in the gun in the window. That kind of sold me on ray tracing. For sure. Oh, he's dancing in the cube. Great for him. With a disco ball! But he never actually talked about the performance it had, not in ray tracing, but in everyday computing compared to its old counterparts. He said that the 2070 was better than the Titan XP at ray tracing. He never said what the FPS numbers are going to be from this thing. So it's, I don't know. There was a lot of hubbubaloo and a lot of explaining himself for this. Now, I guarantee these will be awesome cards. Nvidia hasn't really let us down in that department. And it's going to put a big strain on whatever AMD's got coming down the pipe, because we all see what Hairworks does, Nvidia Hairworks does to an RX card. It fries it. You can't even have those effects turned on, and they don't look as good when they're on an AMD GPU. Ray tracing is going to do that, and it's going to stagnate things. But what I'm worried about is the performance of these things. I want to know that it's going to run games at high frame rates at 4K, and that my 4K monitor, we can start, bringing in more and more high refresh rate 4K monitors and HDR. He never talked about how HDR ties in to this ray tracing. I'm sure that there's some correlation, and it's going to make HDR much better. But he didn't talk about that. It's weird. So all in all, I don't know, man. I think you could just get a 1080 Ti for real cheap, apparently. And there's no way it's going to drive the prices of them down that much. And I guess the used market will be flooded, because if you have a 1080 Ti now, you probably want the best card out there when it launches. I know myself, I've already begun the process to sell my 1080 Ti in a high-end system, so that sale of that system gives me the money to buy whatever comes out come September. So we'll see about pre-ordering it and stuff like that. But maybe I'll get lucky, and he never said anything about board partner variants either. How long are those going to take before the Gigabytes and the Asus cards come out? Because that's where I'm going to get my review sample. Nvidia is not going to be sending me nothing. It'll be one of the board partners. So I guess I'm just going to have to buy it on my own. But at least the cooler looks good. That cooler looks like it's inspired by an EVGA or something like that. So that's pretty cool. But I'm super hungry, guys. I want to thank every one of you for coming and watching this stream with me. This was really, really fun. I love every single freaking one of you. Expect a look back at the performance of the 1080 Ti coming up on the channel in the next day or so. I'm working on testing right now. I want to see what the latest drivers and the latest games, where the FPS numbers stand, so that I have a comparison once I do get my hands on one of these cards. But I'm going to go eat some lunch, and I want to thank every single one of you for watching it with me, and I hope you had a lot of fun, because Jensen didn't ever talk about how it just works. It just works, guys. It just works. I love all your faces, guys. I want to say thank you to J2 Gross, the Big Mac, Core GMR, Amir Sabag, Kirk McQuarrie, Gaugeron, Vinny C. We have, who else is, Fat Dust is talking in there. Mark Burnett. I love all you guys. Swift Silver, JK, Retro Game Kid, Lashing Some Zero, Fetish Snacker. All the fucking people that came out to watch me. I can't, JTZ Tech Reviews. I watch your channel. It's amazing. Furious Moose Knuckles needs more boob ray tracing. Furious Moose Knuckles, you fucking bastard. And all you other people out there. So keep on rocking in the free world. Doot doodaloo doot doot doot.